Hello everyone, welcome to Learn Overflow. In this video, we will discuss about an famous LeetCode problem, house robber. House robber is like a pretty famous, and in many interviews, if you ask this question, you go with Amazon interview, go with Google interview, any of the top interview, this is an usual question that they ask, and then you can expect this question at any interview. So let's start this video. It is given like you are a professional robber. Okay, so they are saying that you are a robber here, and they're saying that who is you are planning to rob houses along a street. Okay, so then it says that each house has a certain amount of money stashed on them. Like each house has certain amount of money. Okay, like each of the house has some of the money in their lockers or somewhere they have money somewhere. Okay, now look here. What else they say? The only constraint stopping you from robbing each of them is that adjacent houses have a security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Okay, so it says that you cannot rob all the houses. If you rob two adjacent houses at the same time, two adjacent houses in the night, then what will happen? It will automatically contact police. Yes, and once the police is contacted, and you're gone. That's the problem. So it says that you need to you cannot rob all the houses. Now, what else is given to us? Like you were given an integer array now, okay, representing the amount of money of each house, like the amount of money in each of the house. There's a num given to us, and in return the maximum amount of money you can rob tonight without alerting the police. Okay, so the question is pretty simple. The question simply says that the maximum money you should rob out here, rob from that house. Okay, so the first thing that comes in your mind when you listen to this maximum minimum or this kind of stuff, the first thing is like whether it's an greedy approach or not. Okay, so see there, what would have happened if you have gone with a greedy approach over this example? Okay, if you have gone with a greedy approach, then you have chosen 2 and 3. That's the maximum money you can earn from it. But if you choose 2 and 3, that means they are adjacent houses and the police will get alerted, right? So you cannot do this thing. So it's now you're clear that it's not a greedy approach. Like greedy won't give you a maximum value over here. Like greedy will give you maximum value, but that won't be the exact asked value for us, right? That may alert the police. So let's try to analyze the question on case by case manner. Okay. Now, what we'll do first, let's see each of the examples and let's try to understand the what can happen. Say there's an only one house. Okay, there's only one house is there, and say there's like one coin is there. Okay, I'm just taking the money in the house being coins. Okay, I'm referring as coins. So there's only one house, then there's only one coin in that house. So what can be the answer for you? Like if our array has only one element, then only that is the answer, right? That's the maximum you can take. All right. So in case our array has two elements, say 1 and 2, then what is the maximum value you can take, right? So if our array has this kind of elements, then we can take the max of element 0 and element 1, right? That's the maximum we can have, like maximum of either these two values, and we find that the maximum is 2, right? So that's all we have. But the problem comes when the array size increases. See, when if we have numbers like say like this, and say we have a value like this. Okay, so if you have numbers like this, then how will you find out? You can find out this by the example of by how we can actually do that. We will see the like we can choose these two houses. If I just change the color, that means you can choose house number 1 and house number 3, right? And on the other hand, you can choose house number 2. Now you need to check if is house number 2 is the maximum, or the sum of house number 1 and house number 2 is the maximum. So that will be the maximum value. Like if you can choose that. So in that case, you find that our only choosing house number 2 will give us a maximum value, right? See, try to analyze the answer out of this. This is a like pretty interesting question. What happens over here is you are trying to analyze that, okay, we either need to choose the sum of these two, okay, or we need to choose the second element. Okay, now let's increase our array size to another level. Okay, say our array has 1, 3, then 4, and then 5. Okay, So let's say our array has this 4 elements. Okay. Now we got our array, and let's try to analyze what can be our answer. Our answer can be like either you choose this two or you choose this two, right? That's what like then we find the sum of them. So either you got like 4 plus 1 is 5, or you got 5 plus 3 is 8. So our answer is actually 8 over here, because we cannot go with a adjacent array. It's like adjacent houses over here. Okay. Next, try to find the actual value over here. Okay. Like I'm trying to analyze, coming to an like a better formula or better understanding to where we are trying to head to. Now say you have another array, say 1, 2, and then 3, like array with 5 elements in total. Okay, I'm just increasing the values to just try to make make a final answer to this. See, when you have 5 elements, we actually see what either we can go ahead with this. Okay, and we can go ahead with this, and we with this, like, okay, that's the sum, or we can have a sum of here. So what we find, that is sum, like 1 plus 3 plus 5, that's 8, or 2 plus 6 is 6. So we find the maximum money that we can take is 8 over here. Okay, so how is we are doing that? We are going to hop the like either we're going to start from 0 question and hop the value from here. Let's see another example with a bigger array of like 6 elements. Say there's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. Okay, there's something we need to think over here. What that? The thing is, we are starting from the like first house. Okay, this array is sorted. Okay, so in that case, I'm just letting you understand for your better understanding. Let's say we took the first element. Okay, then we find that we can take a 3. Okay, or we can take 4, right? Yeah, if we take 1, like if we take 1 plus 3 plus 5, that's a value we can go into, like that will be 9. Or we can take a value like 1 plus say we don't take 3, like we cannot take 2. After, if we select 1, we cannot take 2, that's for sure. So we take 1, then we say we don't select 3, we go for 4 plus 4, and after 4 we cannot select 5, so we go for 5. See, what's the like we go for 6. Okay, so what's the final answer out here? So we find that it's 11. See, we are getting much more values over it. It's not the simple summation like hop each elements. Okay, now we start with say 2, and then 2 plus 4, so that's 4 will be a single hop. We find 2 plus 4 plus then 4, we cannot take 5, we can go with 6, right? So that's what we got. All right, so then we get it's 12. See, which one is the maximum value? You find, like you can understand like how the values are being taken over here. That's what we are trying to understand out of this question. See, it's not only like we're simply hopping each element and finding an answer. It's also that we need to see if the other element can give us a better value or not. Say we have an array and another array. Okay, and another array over us. All right, so that's our dynamic array. We got like the new array for calculation of this. And then what we want to do is, we want to, like, if you're going for the 6 elements, we'll make sure that its length is 7. Okay, we want to make sure that it's like length plus 1. Why so? The main intention behind this is like we'll make the first element as 0 as it is. Okay, that's the first element as the 0. Then the next element will be its 0th elements, like the 1. That's how we want to store. And then the second element will be is the second element. Okay, that's the initial positioning we are going to get. Look the thinking process out here, what we are trying to do. And the first element we keep it 0 as it is for our ease. Okay, now see we are done with this amount of array. Okay, now we need to find. So what we actually did, we actually took our first positions that we can actually take. See, this is the first 1 or 2 is the only thing that we can find out here, right? So that's the stuff we are going to get here. Now after that, we are getting 3. Okay, so for 3, what will we do? We will check for 3 plus we will go ahead with a -1. Like for 3, we cannot take this value, right? We can take this 0th value, like this 1. So 3 plus 1, or like max of this, or what we can take. So at this position, we'll just look into the thing like if we're taking 3, we can take 1, or we can take another value before it. Right, that's why we took an additional 0 in our DP array, so that we can support that functionality. That was the thing we were doing here. Either take after 1, either take 3 or take 4. So we find a value out of it. So after 3, so we'll go plus 3 plus this one. Like we cannot take 2 at any position if we're taking 3, right? So we'll go for 3 plus 1 or 3 plus 0. 0 being this position. So 1 we're taking, 1 is actually coming from this one. So we are just trying to add this, that the given array nums, we're trying to find the nums of I plus this dp of I minus 1. We are trying to find this position. Okay, so dp of I minus 1 or I minus 2, whoever is the maximum, make a sum with the nums of I, right? Okay, so that's the thing we're trying to do. Like we cannot take the I minus 1, so we'll go with I minus 1 or I minus 2. We cannot take this position, right? So that's the basic idea behind this. So we find that this is more or less 4 will be our maximum value over here. Okay, then we'll like this part is done. So next we'll go with 4. Okay, now for 4 we can have 4 plus 2 or 4 plus 1. See, here we'll understand better. Like if we go ahead with 4, now we can have 4 plus the second position is we are finding for this position. So this position, that's the 4, but plus 2, we are not taking its adjacent, right? We are not taking its adjacent is 3. We are not adding this. 4 plus 2 or 4 plus 1, right? So 4 plus 2, comma, 4 plus 1. So whatever be the maximum will come here. Okay, so we are going ahead with an cumulative sum of all the elements. Now you'll understand how this is a cumulative sum. The cumulative sum being when it comes over 5, so 5 plus 3 or 5 plus 2. Now you'll see this is not the actual value. 5 plus 3 will be 8 or 5 plus 2 will be 7. So that won't give us value. If we're taking 5 plus 3, then we should take 1 also. If we're taking 5 plus 2, then we should take if other values are there also. So we'll take the value from this DP array. How is it so? So we'll go ahead with 5. Okay, 5 plus so we are filling for this position. We cannot take the cumulative value at this position, right? Then previous array of the adjacent home we have over here. So we'll go for 5 plus 4 or 5 plus 2. That is the value we have over here. Okay, so 5 plus 4 or 5 plus 2. That's the we are going to find the max of this. So we find that this is the 10. See, that's the cumulative value we got. That's the value we have over here. So 5 plus 4 or oh, sorry, what did I write? 5 plus 4 is 9. I'm sorry about that. So 5 plus 4 is 9. We find that value. Now, for the last element, see how we can go ahead. For the last element, we are finding a position at this. See, these are our 6 values we have, right? So at the position of this value, we are finding this 6 plus 6 or 6 plus 4, right? So that's the idea behind this. So we'll go ahead with, that's the idea, like 6 plus 6 or 6 plus 4, right? We got 2 values and we find that this is 12. See, if we like while we calculated manually, we find that 12 being the largest value for us. And when we found it in a programmatically format or in a logical format, we find that yes, this is the 6 plus 12 being the maximum value is given to us, right? Now it can have a different scenario. Look, it can have a different scenario. Think carefully. If this like 6 plus 6 is not the maximum value, if like this value may have been the maximum value out here, like it's not a sorted array, so you cannot find a value at the last position. So it may be like this position of a maximum value. So our final result will be the max out of the last 2 elements we have over here. Okay, so that's the basic idea behind finding this whole like the house robber problem. So I hope it's understandable to how to go ahead with that. First, we should go check this best conditions, and then from this third positions onwards, we can have a look for like the whole array and just find out what we are trying to find, right? So I hope it's understandable. Let's try to code it a bit faster and try to understand exactly how this code works. All right. So in this particular code that I wrote over here, I did what? I exactly did like the initial best guesses. Like if the length is 1, return the 0th position. If the length is 2, return the max of the 2 elements that we have. And then we just created an DP array for us. I named it a DP. And then I just filled in the first position, the second position, not the 0th position, with the 0th and the first position values of our nums array. And thus DP of 0 is 0 by default remains so. Okay. Next, we just ran a loop from I equal to 2 till length being the length of our nums array, remember. So what we did, we just went ahead with DP of I plus 1. Okay, remember, this is like the plus 1 in every case. The originality, it was 0, so it plus 1 going on in every case. So we went ahead with the DP of I plus 1. So this ith loop is a loop of nums of I. Okay. So we are going with that. Now DP of I plus 1, we are storing in it. And then what we're doing, nums of I being the added element. And then we went ahead with a maximum of either the previous element, like previous the nums are element. So it will be like we are going ahead with this position. If we're going with the sixth position, it will be like fifth position, not fifth position, the fourth position or the third position being judged by this elements. Okay, I minus 1 and I minus 2. That's how it's working over here. Okay, like if I just write over here, say I is case is something like 2 and 3, like something like this values. Say our I is 6. Okay. And then in such a case, what will be our I plus 1? I plus 1 will be, remember, like 7, right? That's our I plus 1. And then we are going with I minus 1 and I minus 2. That means we are going with the fifth and the fourth position. We're checking with those being over here, okay? There shouldn't be any confusion out there further. And ultimately, what we are doing, ultimately, we're just finding the maximum of the two elements, being the last two elements of our DP array, and just returning out from there. So let's go ahead and let's run this code and try to understand how this code exactly works. Okay, so let's run this and find out whether it works or not. Yeah, so you can see it actually works for us. Okay, so that's how it actually works, and we can go ahead and actually submit the code. Yeah, so let's see what happens if we submit the code. Yes, it's 0 ms because that's the pretty much easier solution we have over here. Okay, so that's how we actually can find out a good solution to this question. All right, so I hope I can make you understand how this particular question, that house robber problem, can be solved using with the help of dynamic programming. Okay, so that's how that's the main motive of this question. So I hope I can make you understand. Hope to see you soon in my next video. By the way, you can comment below your thoughts, or if you want any particular question that needs to be discussion, make sure you just comment your comment about the question in the comments, or let me know about that question rather. Also, make sure to subscribe this channel and like this video and share it with all of your friends who want to learn the basics of dynamic programming. Thank you all for watching this video. Hope to see you soon in my next video. Bye.